All right, here we go. Looks like a lot of people left number 20 blank. Was there too much writing for you? Too much reading? Page. Yeah, I'll go over 14 too. 20 we actually did in class. Write expressions for the tangent of each acute angle. Well, what are the acute angles in this triangle? A and B. So what's the tangent of A? What's the tangent of A? A over B. What's the tangent of B? All right. Explain how the tangent of one acute angle is related to the tangent of the other acute angle. How are these related? They are?
Reciprocals.
Just reciprocals, right? They're just reciprocals of one another. We talked about that yesterday. It was like 18 over 80 and 80 over 18. And yeah, I think it was one of the examples we did, right? All right. What kind of angle pair is A and B? We talked about that too. Complementary. And then, Paige, you asked about 14, was it?
Yeah.
All right. Scientists can measure the depths of craters on the moon by looking at photos of shadows. Estimate the depth D of the crater. All right. So, Paige, help me out. What did you set up?
I said tan 55 and then equals 500 over D.
Okay. I think that's where we went wrong. From this angle,
I used the other one. The one.
what did you call that angle? Here. Careful.
I mean like the 55.
Use that angle?
Yeah.
Okay. Do you see how that's not an angle on that right triangle?
Yeah.
So tangent of 55 equals, this would be opposite over adjacent. So it would be D over 500. And then multiply both sides by 500. You good? Any other homework questions? That's tangent. Okay. Today we're going to do sine and cosine. If you felt, it seemed like you guys felt pretty confident with the tangent ratio in solving problems. If you can do that, you can do today.
I got a calculator.
Awesome. Where'd you get it? Get an extra one. What a sweet friend. All right. Sine and cosine ratios. What do you think? Sine and cosine ratios are trigonometric ratios for acute angles that involve the lengths of a leg and the hypotenuse of a right triangle. So sine and cosine are spelled this way. They are abbreviated this way. You know how certain things in life you go on saying and nobody ever corrects you, and then you get laughed at in public because you said something a weird way. Have you ever done that?
No. Yeah.
Or saying the wrong lyrics in a song. It's like, oh man, I thought those were the lyrics for like 5 years. I don't know. Anyway, I'm going to protect you. I'm going to be honest with you guys. If you pronounce this sin and cos, okay, I'll correct you politely and gently the first time. Then we'll make fun of you the next time, okay? No, I won't. But sine and cosine, even when abbreviated, are still pronounced sine and cosine. It's not sin and cos, okay? And tan is still tangent. So if we say the sine of 45 degrees, we're not going to say sin 45, all right? We're not going to do that. So down in this triangle, we're going to learn what the sine ratio. Tangent was opposite over adjacent. Tangent did not use the hypotenuse. Sine and cosine do. So the hypotenuse, which some of you like to highlight, is right there. So, do you see how both of these are talking about angle A? Do you see how it says opposite of angle A and like adjacent to angle A? Let's use angle A for our notes, understanding we could also do angle B, and I'll do angle B in just a second, okay? So right now our pencil is on angle A. Are you with me? The sine of angle A, so in your notes, in this little box, in this parentheses here, it's always the sine, cosine, tangent of one of the acute angles. We're not going to use the right back up. We're not going to use the right angle until algebra 2, pre-calc. So don't worry about that right now. All right. It's always of one of these two acute angles for this class. So the sine of A is the opposite side divided by the hypotenuse. Sine of angle A is the opposite side over the hypotenuse. That's for any right triangle. Now, what is it for this right triangle? What sides are those? That is, now I didn't call it little a or little b or little c like yesterday. It's side BC. Isn't that the opposite side? Side BC? Opposite side? Over AB or BA. That's the hypotenuse. Now, we're going to have x's, we're going to have numbers when we start doing problems with these. That's just in general. The cosine of angle A is the adjacent side over the hypotenuse. What's the adjacent side to angle A?
CA.
AC or CA. And the hypotenuse again is AB. The hypotenuse does not move. The hypotenuse does not move. Now, just for a quick exercise, what would the sine of angle B be? Well, now I'm up here at B. Do y'all agree? What if sine is always opposite over hypotenuse? Everybody see where my finger is? What's the opposite side? CA or AC? And then the hypotenuse is still BA or AB. Got it? So it just depends. It's always opposite over hypotenuse. It just depends which acute angle we're on. It is. It's not that bad. All right. Find the sine of S, sine of R, cosine of S, and cosine of R. Write each answer as a fraction and as a decimal. So sine of S, sine of R, cosine of S, cosine of R. We'll write as a fraction first, then as a decimal. Again, baby steps. We're not solving for anything yet. We're just practicing writing the ratio. Well, the hypotenuse is 65. Okay, hypotenuse is 65. So that should be the first thing you do. You're like, okay, that's the hypotenuse. That can't be an opposite side. That can't be an adjacent side. That's the hypotenuse. So if I'm up here at S, who can raise their hand and help me out with the sine of S? Sine of S. Christiana.
63 over 65.
63 over 65. While we're at it, let's type it in our calculator. We'll just type in 63 over 65. It's going to be really close to 1, maybe 0.98. I don't know. 60.
It's pretty much
65. Yeah, 0.969. 0.969. We'll get in the habit of rounding to 2 or 3 places. 2 or 3 places. All right. Calculus, if you make it to calculus, if you decide to keep going with honors math and senior year, have calculus. 3 decimal places all year. So it's a good habit to get into if you want to practice that. All right, sine of r. Well, now my finger's down here at r. What's the opposite side from r? Tally, what do you think? Opposite side?
So 16.
16 over
65.
16 over 65 is 0.246. 0.246. Jared, help me out. What's the cosine of S?
It's going to be 65 or 16 over 65.
16 over 65. Should we type that in our calculator? It's 0.246. Ryan, you got this? Cosine of r. That sounded confident to me.
63 over 65.
Are you sure? I am.
Yeah, I'm sure.
Thank you. I knew it. I just knew that confidence was there. 63 over 65. Ryan, should we type that in?
No.
Why not?
So we already did it.
Yeah. Is this a coincidence? I know it's new to us still. I know this is very new. Can anyone make a conjecture about what two pairs will always be the same? Ryan.
The sine of one of them and the cosine of the other.
Good. Very good. Do you guys agree? Watch. Acute angle, acute angle. What was opposite of this one is going to be the adjacent of this one, right? So aren't those numbers going to be the same? And the hypotenuse of the denominator for both. That's going to happen every time. So, what do you notice about the sine of S and the cosine of R? Same. All right. And why is this true? Because the opposite of one is the adjacent of the other.
You go that one.
I would love to. Yep, this is one. These are some more blanks for you guys to fill in. This is kind of the explanation why it works out that way. Actually, I'm going to ask you to pause for about 10 seconds because I want this is worth you seeing. Okay, instead of just writing down and getting distracted. I'll eyes up here for 10 seconds. 10 seconds. Do you understand what it means 90 minus A? Well, not really. Do you agree R and S add up to 90? What if I tell you R is 30? This is going to be more than 10 seconds, so don't hold me to it because I wasn't sure if you guys were going to get this or not. If that's 30, what's this angle? How'd you get that? The complementary. 90 minus 30 is 60, right? What if this angle is 10? That angle's 90 minus 10. 90 minus R. Do you get it? So what does that mean? A and B are always complementary. The cosine of B came from 90 minus A. Did that make any sense at all?
Not really.
We just showed why the sine of A equals the cosine of B. Do you guys know what a mnemonic device is?
No.
Roy G. Biv.
Oh,
What's
yeah.
that?
That's color.
Colors of the Rainbow. Did you remember Roy G. Biv?
Yeah.
What does it stand for? Red, orange, yellow. So it stands for something. It's a way to remember something. Please excuse my dear Aunt Sally. Did you learn that one? Order of operations.
Okay.
PEMDAS, right?
Yeah.
Order of operations. Okay? That's a mnemonic. It's a way to remember something. A mnemonic device. Okay? There's a mnemonic device for sine, cosine, and tangent. It's kind of to help you remember it. All right? and this isn't actually on your paper. Let's find a spot for it. You know what? I'd probably put it at the very top. I'd put it at the very top if I were you. Isn't the sine of an angle equal to the opposite over hypotenuse? Yes? I'm going to put O for opposite, H for hypotenuse. With me? The cosine of an angle is the adjacent side over the hypotenuse. And the tangent of an angle is the opposite side divided by the adjacent side. Now, we know that's how we set it up to solve problems. But to memorize it, some people, across the world memorize it this way. I guess English speakers. As so ka toa. So ka toa. So sine, you have to know what it means. You can't just say, oh, so ka toa, and then expect to memorize it on a quiz. Like, you have to know how to use it. So sine of an angle equals opposite divided by hypotenuse. So this order, always up here, this order tells you which one, sine, cosine, tangent, and then what the numerator is, and then what the denominator is. Cosine, numerator, adjacent side. Denominator, hypotenuse. Tangent, numerator, opposite. Denominator, adjacent. That's the mnemonic device for trigonometry. So ka toa. Or I've heard it said, some old horse caught a horse taking oats away. I don't know. I just memorized so ka toa. But then I figured out that some students misspell so ka toa, and then it's not helpful at all. All right? Just like if you misspelled PEMDAS, then it wouldn't be helpful. Right? But however you want to memorize it. So ka toa. So ka toa. Actually, it was Sacagawea's sister, but nobody ever gives her credit. All right, write sine of 56 in terms of cosine. The sine of 56 would be equal to the cosine of blank. What do you think? I heard 34. Do you agree? The sine of 56 equals the cosine of 34. Madison agrees, right? How could we check it? We could type it in a calculator, couldn't we? Let's type both of these in our calculator and see if they're equal. Type in the sine of 56. Right next to the tangent button, I think. They're close. Wow, says the girl that just now got a calculator. Are they equal? Sine of 56. I'm getting 829. Cosine of 34. 0.829. Oh, look, they're equal. That's what we just wrote on the last fill in the blanks. The sine of 56 should equal the cosine of the other angle, right? What's the other acute angle? 34. Down.
So the missing one is just complementary to.
Yes. Yep. So ready? Visual. 56. The sine of 56 would be this side over this side, right? This side first. This side is the denominator. Isn't this angle 34? What's the cosine of this side? Well, adjacent over hypotenuse. Oh, look. They're the same. If they're the same ratio, then they're equal. Now, let's do it in real life. All right, let's practice. Now, you don't get to decide all the time whether you're going to use sine, cosine, or tangent. The problem will tell you. All right? We don't know. the problem will tell us. All right. Here we go. Do you guys want to find x first or y first? Preston, what do you say? X or y? X. All right. Now, obviously, if that's my unknown, then I need to use the acute angle that they gave me. I could find the other acute angle. That's just too much work. I'm being silly. All right. Ready? Here's my pencil. Other thing I kind of recommend is that we identify the hypotenuse. Do you all agree? That's the hypotenuse. Here we go. If Preston decided to find x first, we don't have a choice whether to use sine, cosine, or tangent. What are we going to use? Well, from this 26-degree angle, I'll ice up here for a second. We have to use x, don't we? From 26, what is x? Opposite, adjacent, or hypotenuse? Opposite. I can't use y. That'd be two unknowns. So I need to use the hypotenuse. If I'm using opposite and hypotenuse, that tells me I have to use sine. Sine, not so, not sin, sine, okay? So the sine of 26 degrees equals, I don't get to decide the ratio. Sine is always opposite, x, over hypotenuse, 14. Does everybody understand how I set that up? Now, I just have to multiply both sides by 14 to get my answer. Times 14 times 14. So x equals 14 times the sine of 26 degrees. And by the way, I gave you guys credit last night for doing the homework. Even if you didn't show a ton of work, but I'm going to start requiring you have to set this up. If you don't set this up, if you just put in an answer, you might have gotten the answer off of whatever, you name it, right? There's a bunch of places you can get answers here. I want to see your work. So no work, no points. I got 6.137. 6.137. Some people may round to 6.14. Did everyone get 6.14?
Yes.
6.14. Now, I want to find y. I'm still going to put my finger on the 26-degree angle but this time, y is the
Adjacent.
y is the adjacent side. Do I want to use the 6.14? Probably not. What if we got that wrong? Let's use the 14. 14 is the hypotenuse. Adjacent and hypotenuse tells me to use cosine. So the cosine of 26 degrees equals, what goes in the numerator, y or 14? Y. Because it's the adjacent side. What's the same thing?
The sine and cosine.
It's not. Let's type this in our calculator. Ooh, Liv, you got a calculator now. Let's type it in. Times 14. Times 14. Y equals 14 times the cosine of 26 degrees. 14 times the cosine. That's what I got. 12.583. 12.583. Why wasn't it the same as the other one? It's a different function. It's cosine. Right? No, wait. What would it be if it's the same? It would be the cosine of the complement of 26. They would be the same. Page. Is that what you're going to say?
Yeah.
We just solved for both sides in this right triangle. Question. A student once wondered, Mr. Westphal, I have 6.14 for this side. and I have the hypotenuse, can I just use the Pythagorean theorem to find the other side? McKenna.
Wouldn't you need like two sides?
Yeah, but once we found 6.14, if we wanted to find y, so after Preston found x is 6.14, and we knew the hypotenuse was already 14, could I do this? 6.14 squared plus y squared equals 14 squared. Let's see. 14 squared minus 6. I'm going to type in 6.137 because that was more accurate. And then square root that answer. I got 12.583. Ooh, interesting. That's the same as what we did when we used cosine, right? Come on, that's kind of cool.
Yeah.
Trig, Pythagorean theorem, same answer. All right, you guys try.
Like all of these? I don't even know.
Yes, McKenna.
So can you use that to like check your work?
Absolutely. That's a great idea. Check your work with a Pythagorean theorem.
Okay.
Got this one? Can I ask a real question with you? If they don't call off school tomorrow, will you still come?
Probably not.
She's got her mind made up. She's like, I am not.
Because there's still a chance that very well be school tomorrow.
Get one. Jesus, so basically freezing. It's like worst case is be school Friday and then I get to go skiing. It's just one matter.
I hope we don't have school Friday either.
Well, that makes
Like that's
sense.
my extended attention on the
You're right.
It's okay, we get to you.
Sorry, just speak louder so the entire class can hear you too.
7.25.
Wait, you can still yes, but yeah. Oh, God, with the decimals, dude. Come on, it doesn't say. No. Yeah, everything has decimals.
Okay, the color is the adjacent.
Yeah, you're supposed to. See, what if you're wrong?
That's wrong.
You're not. You put 3, 3, 4, 9. It's actually 3, 3, 4, 8. And you put it right now. You stop making those things. Draw that.
Yeah, that's why I received it.
I can do that.
Or
18.694.964. But I got the same answer. 2.725. Oh yeah.
Well, I do, but
8.1. I just wanted to see.
Did you get those two values for U and for T?
Yes.
Pretty similar to the tangent, isn't it? I mean, it's the same process, just a different. It's called a function, by the way. When you get into algebra and pre-calculus, sine, cosine, and tangent are going to actually have their own graphs, just like a linear function is a line, just like a parabola is a curve. These are curves of their own, with really interesting applications. But this class doesn't seem to care about that. But whatever.
I care.
A slinky goes up and down on a sine curve path. Electricity travels through circuits in a sine wave. The amount of daylight in a day is a sine curve. Amazing. All right.
Actually, you do it to the nearest time.
Let's think about this one. I want you guys to talk to your table partner. Be careful saying, talk to your friend. But talk to your table partner about which one of these does not belong. Then we'll talk about which table partner. Ouch.
No, because the tangent B is the opposite of x. It's not the hypotenuse. Yeah, but the tangent, the cosine and the sine use the hypotenuse. So does the AC over BC.
I don't know. Actually, I do.
So just look at it. The tangent of B is the two sides that aren't hypotenuse. The cosine, sine, and then the AC over BC are both. Well, not both, or all three using the hypotenuse except for the tangent. Yeah, see that? Okay. That's pretty cool.
Oh, it's tan.
Then why did you look like you were listening? That's not. It's kind of mean. You literally made me waste words. Okay.
Which one does not belong? Tangent of B.
Told you.
Questions on that one? Ryan.
Why?
Oh.
Discuss it.
All right, ready? Real quick, Ryan. Sine of B. It's this side over this side. AC over BC, right? That's the ratio. AC over BC. Cosine of C. This is the adjacent, and that's the hypotenuse. Same ratio. Same ratio. Different ratio. That's AC over AB. All right. Well, let's do this one quickly to get to some of the applications. There's the acute angle. What are we trying to find? A leg or the hypotenuse in this one? Hypotenuse. There's the hypotenuse. Am I going to use sine, cosine, or tangent for this one? Not tangent. Tangent doesn't use the hypotenuse. Well, here I am. I'm given the, what's this side from 21? Opposite. This one's the hypotenuse. Opposite and hypotenuse tells me to use not so, not sin, sine. I saw the sign. It opened up my eyes. I saw the sign. Is it 1200 over x or x over 1200? 1200 over x. Opposite over hypotenuse. Now this one, you cannot just multiply and be done with it. You got to multiply and then divide because of where x is. 1200 equals x times the sine of 21. I will warn you right now. I have a bunch of students get this wrong because they don't take the time to do both steps. One step gets x out of the denominator. The next step solves for x. I have to actually divide both sides by the sine of 21. X equals 1200 divided by the sine of 21. It better be more than 1200 because it's the hypotenuse. 1200 divided by the sine 21. I get 3,348.51 feet. And then I look up to the answer or the question and see if they ask me to round in a specific way. Nope. So I will leave it that way. Does that make sense? Be careful. I'm telling you right now. When the unknown is the hypotenuse, it has to go in the denominator. Both sine and cosine have over hypotenuse. Over hypotenuse. You're gonna have to do two steps to solve for it. Cross multiply. and divide.
This has to be 7%. That has to be.
All right, from the top of a lighthouse. I'm not an artist. I apologize. More like a water tower or a marshmallow on top of a pyramid. All right, from the top of a lighthouse, 190 feet high. All right, the angle of depression to a boat out at sea. It's a dinghy. The angle of depression is 34 degrees. Okay? Find to the nearest tenth of a foot the distance from the boat to the foot of the lighthouse. Isn't this X? Now, here's the deal. I want to warn you right now. Be careful where you draw the angle of depression. What did I say yesterday? It's always from the lighthouse. Ready? To the boat. This is the line of sight we're talking about, yes? Where is the 34-degree angle? Angle of depression. It's always from the, what did I tell you yesterday? It's always from the imaginary horizontal line. Ready? Imaginary horizontal line going, well, depression, down 34 degrees. I'm warning you right now, that gets messed up all the time. That's not an angle in our triangle that we want, is it? Because look, here's our right triangle. There's our right triangle. This is 190. This is X. I want this angle. I want that angle right there. What is that angle? 56. Very good. $56 degrees. Do you need me to go back through that, or are you okay? Because look, the imaginary horizontal and this vertical make a 90, right? So if this one was 34, this one had to be 56. Or you could think alternate interior, like this, alternate interior. And then that one's complementary to it. Either way, I don't care. All right, last problem for today. So I'm at the 56-degree angle. I need to use what two sides? This one is the opposite and the adjacent. Do you see it? Opposite and adjacent. O and A tell me to use tangent. So the tangent of my angle, 56 degrees, equals the opposite side, which is X, over the adjacent side, which is 190. Because X is in the numerator, I just have to multiply both sides by 190 and type it in. I get 281.69 feet. Quick word of warning, it's going to happen to some people, and I don't want it to mess you up. What if you did this in your calculator? Tangent of 56, you didn't close the parentheses, and you did times 190. It messes you up, doesn't it? If you put the 190 after, you have to close the parentheses. If you put it before, it won't mess you up. I always put it before. Let's read. Did it say nearest 10th? So we're going to say 281.7 feet. All right, the problem we did not get to, I'll give you a hint. You've got two different boats you're looking at. You might have two different right triangles you have to include, all right? That's an optional problem. We know who's not going to do that one. All right? There's your homework for tonight.
That's a lot of homework. Wow.
You're welcome.
That's a word.
didn't even look at it yet. How do you know it's a lot of homework?
That's a lot of questions.
What if it just said, let's find the sign of R? Oh, 2/5. Done.
You're hurting my soul.
Let's see if you guys do world records. Let's see if you guys do world records.
She was after I said she's got a test.